Hello students, welcome to Educate. Today we are going to continue with question number 8.11 of chapter 8. Up to here we have done in previous lecture, so I think you must have seen them. So let's continue. Here information is given. Let's read the question. A 14.5 kg mass fastened to the end of a steel wire of unstretched length 1 meter is whirled in a vertical circle with an angular velocity of 2 revolutions per second. At the bottom of the circle, the cross-sectional area of the wire is this much, 0.065 centimeters square. Calculate the elongation of the wire when the mass is at the lowest point of its path. So here what you can do, you can consider a circle and weight mg will be in downward direction and tension will be in upward direction. So what is centripetal force here? So centripetal force is equal to difference of the two. So T minus mg. Centripetal force is given by either mv square upon r and v equal to r omega. So m r omega square equal to tension minus mg, and you know the elongation will be due to tension. So let's see what is tension. Tension will be mr omega square plus mg, and omega is 2 pi, omega equal to 2 pi by t or 2 pi into frequency. Here frequency is given as 2 revolutions per second, so just write it 4 pi radian per second. So we have got the value of omega also, and m is also given 14.5, so write here 14.5 and keep it common. Radius is means length of the wire, that is 1 into omega. Omega is 4 pi, so 16 pi square plus m is already out, and g say 9.8. So 14.5 into 16 into say 9.8 plus 9.8. We can simplify. So from here we will get tension, that is around, so tension will be T will be equal to 2431.94 Newton. So up to here there is no problem. Now we have to find out delta L, and you know how to find delta L. F upon A delta L into L is Young modulus, and this is a steel. So delta L is equal to FL divided by A into Y. So force is, we have calculated this much, 2431.94 into length of the wire is 1 divided by area of cross section is given in our question 0.065 into 10 to the power minus 4 into Young's modulus for steel 2 into 10 to the power 11. Now all that is left for you is the calculation. Let's see here, this will make this 10 power 7, it will go in numerator. So 2431.94 multiplied by 10 to the power minus 7, and from here 3 power more positive, so this will become 65 into 2, and then try to simplify. Take 1 minute to get the answer. This will come out to be 1.87 into 10 to the power minus 3 meters. I think process you have understood. There is nothing tough. Only calculation is there that you can do. Let's go to next question. Next question says, compute the bulk modulus of water from following data. Initial volume 100 liter, pressure increase 100 atm, final volume 10.5 liter. Compare the bulk modulus of water with that of air at constant temperature. Explain in simple terms why the ratio is so large. So here I'm going to solve the numerical portion. The information given is pressure. Bulk modulus K is given by pressure into volume divided by change in volume, right? And here information given is final volume is V final is given as 100.5, V initial is given as 100. Both are in liter. So change in volume delta V will be 0.5 liter or 0.5 into 10 to the power minus 3 meter cube. So we have information of delta V, and initial volume is also we are having, so there is no problem. And we have to find out bulk modulus, so no problem. K is pressure. Pressure is given as 100 atm, so 100 times 1 atm value is given 1.013 into 10 to the power 5 into volume original. Original is 100 into 10 to the power 100 liter. So you know 1000 liter equal to 1 meter cube. So 1 liter is equal to 10 power minus 3 meter cube. So here pressure we have written, and then volume is 100 liter into 10 power minus 3, right? Whole divided by change in volume. Change in volume is 0.5 into 10 to the power minus 3. So 10 to the power 5 minus 3 will cancel out from here. 0.5 will become 5 upon 10, and then everything is simple. So 5 upon 10, let's write this 100 as 1000 for this, and 5, then here 1.013 into 10 to the power 5 plus 2 7 plus 3 10. Simplify. So it is simple. So what will it be? K equal to, just check. Around it will be 2.026 into 10 power 9, and the unit of K will be Pascal. Understood? Now we are going to see next question. What is the density of water at depth where pressure is 80 atm, given that its initial density at the surface is 1.03 into 10 power 3 kg per meter cube? So let's see what change in pressure occurs. So at the surface pressure will be 1 atm, and at depth, what is density of water at a depth where pressure is 80 atm? Here 80 atm. So pressure difference delta P you can say. 79 ATM. Is it okay? So let's gather information first, and after that I will solve it. Density at the surface is given rho, say 1.03 into 10 to the power 3 kg per meter cube. Right. Up to here, there is no problem. So 1 ATM value of 1 ATM is 1.013 into 10 to the power 5 Pascal. We can write this. So let's solve it systematically. So pressure difference, let's write it, pressure difference as P, and then it is 79 ATM as I have shown you. So 79 into value of 1 ATM, that is 1.013 into 10 to the power 3, and this is Pascal, right? Not 3, sorry, it's 5. So we have got the value of P, change in volume. So change in volume delta V 0.5 into 10 to the power minus 3 meter cube, right? And the density in the beginning is given, so later on we will make use of it. Now here we also need bulk modulus. So here come, what is density of water in there? This, yeah, bulk modulus will also be needed. So for that we will put the value. We will take known value if no more information is given. Okay, so we can use the table for solving this question wherever need be. Let's see that. So now we write the formula for K equal to P into V divided by delta V. We have value of neither K nor compressibility is given, but there must be some value, right? So let's proceed. Later I will put, so delta V upon delta V is given, and V is also given. So delta V upon V. So delta V upon V will be how much? It will be P upon K. And pressure we have, pressure we can write from here 79 into 1.01 into 10 to the power 5 into 1 upon K is compressibility. If compressibility is given in question, something will be given, either bulk modulus or compressibility. If compressibility will be given, so 1 upon K will be the compressibility. So here I am writing the value of compressibility 45.8 into 10 to the power minus 11. And then we can simplify it. So we will get how much? 3.665 into 10 to the power minus 3. So up to here there is no problem. Is it okay? So we have got the value of delta V upon V, but let's analyze this. Delta V upon V is what? This is V dash minus V. So original volume will be larger because at depth density will be more. So V minus V dash divided by V. And if you remember, mass upon volume equal to density, and we are given V, so V will be mass upon density. So we can write it like mass upon density minus here mass upon density dash, here it will change density, divided by mass upon density, right? So we will get what? This we take M will get cancelled, so this will become rho dash minus rho divided by rho into rho dash multiplied by rho So we have got the value. What? One row will cancel out. So 1 minus rho upon rho dash. So this value we have got. Delta V upon V is equal to 1 minus rho upon rho dash. But delta V upon V, we have evaluated at this much. So we write that value here, 3.665 into 10 to the power minus 3 equal to, we have got this as 1 minus rho upon rho dash. So 1 minus rho upon rho dash. Our concern is to get rho dash. Value of rho is given. So what you do, rho upon rho dash, you write 1 minus 3.665 into 10 power minus 3 and then evaluate it, invert it, and then you can get a rho dash. Rho dash will be, if you invert it, so you can easily get where a rho is given in our question. What is value of rho? So rho is given 1.03 into 10 power 3 kg per meter. So calculation is your part that you can do, and after evaluation you will get 1.034 into 10 to the power 3 kg per meter cube. It is 1.034 into 10 power 3 kg per meter cube. Sorry. Now, next question is compute the fractional change in volume of glass slab when subjected to a hydraulic pressure of 10 PA or 10 atm. So 10 atm means what? So here pressure is given as 10 into 1 atm is 1.013 into 10 power 5 Pascal. So this is value of pressure that is given. So compute the fractional volume which is glass slab when subjected to hydraulic pressure of this much. So let's evaluate. And here we need the bulk modulus of glass. So from table we have to evaluate, we have to get it bulk modulus. Say we write it as K. Its value is given as 37 into 10 power 9 Pascal. Okay, so we have pressure, we have K, and we need fractional change. Fractional change, it means delta V upon V. Now it is easy. So formula is bulk modulus K equal to P divided by here delta V upon V, right? So we need this thing. So we can write here delta V upon V equal to P upon K, right? And then we can put the values. P is 10 into 1.013 into 10 power 5 whole divided by K is as 37 into 10 to the power 9. So here power we can adjust 10 multiplied by 1.013 into 10 to the power here 5 minus 9 divided by numbers 37. So if we simplify, so delta V upon V, just do division. So you will get 2.74 into 10 to the power minus 5. So that is the answer. I think thing is clear. Little complicated calculation is involved, but you can do. Here I would like to tell you one key concept. Always keep in mind some important factors. There is one principle. It says if any one can do. Why not I? While solving any question, keep this in mind. Never get desperate. Even if you can't do, take time. Intelligence lies within you. You know, teachers are like matchstick. They can the fire, ignite the flame, but fuel is within you. It means intelligence lies within you. You have to try and you have to show it. So for that, even if some difficulty comes, it does not matter. You will overcome. Here I would like to tell you one important story. Or here just I will tell you one concept that in this world there are three types of human beings. Three types of people are there. So after that you will understand that where you stand and what you can do. So three types people are there. Number one, the lowest category. Lowest category means those people who have fear. With fear, they don't start the work. They think that they can't do. So you should not fall in that category. Second category people are those people who start the work, but they quit it in between when difficulty comes. They think that they can't do. So this is second category. And third category is called a superior category. In superior category, those people fall who start the work. Even if difficulty come, they don't quit till they reach the goal, till they get the solution. So you should be in third category. You should try even if difficulty comes, that does not matter. You can get the result. Right? So I think you will try to be in third category, in superior category, not in second category, not in first category. Right? So let's continue. The next questions. Next question is question number 15. Determine the volume contraction of a solid copper. Determine the volume contraction of a solid copper cube 10 cm on an edge when subjected to hydraulic pressure of 7 into 10 to the power 6 Pascal. So here in this question we are given a cube. So let's find out the volume of the cube. So volume will be side cube, A cube. So volume here side is given as 10 cm, 0.1 whole cube. Right. Hydraulic pressure. So hydraulic pressure is pressure 7 into 0 into 10 to the power 6 Pascal. Right. And you have to find out volume contraction of solid copper cube. So delta V is to be found, and here value of bulk modulus K for copper is given as 1.4 into 10 to the power 11 Pascal. So you have information about P, you have information about volume, and you have to find out delta V. And what is the formula? So formula is bulk modulus is given by P into V divided by delta V, and the delta V will become how much? Delta V equal to PV upon K. Pressure is given as 7 into 10 to the power 6. Volume is given as 0.1 whole cube divided by bulk modulus is given as 1.4 into 10 to the power 11. Let's simplify. 7 into 10 to the power 6 into here 10 to the power minus 3. I think you have understood how 1.4 into 10 to the power 10 to the positive 11. Right. Further simplification can be done. 7 into 10 to the power 6 minus 3 minus 11, from there divide by 14. So we can simplify. We will get around, not around, just 5.0 into 10 to the power minus 8 meters. Here we need delta V, meter cube. We can convert it into centimeter cube, but that is not necessary. Let's see next question. How much should the pressure on a liter of water be changed to compress it by 0.1%? So here percentage change is given. 1 liter volume is given. 1 liter, that is 1 into 10 to the power minus 3 meter cube, and compression means delta V upon V is given as 0.1%. It means what? 0.1 divided by 100, or 0.1 into 10 to the power minus 2. Up to here there is no problem. And one more information is that bulk modulus of water, so not given, so we can take the help of table. So it is 2.2 into 10 to the power 9 Pascal. So now we have information delta V upon V. K, we need P. So we know the formula K equal to P V divided by delta V, and here we are given delta V upon V, so we just need P. So we can write like this: P equals K times delta V upon V. Let's put the values: 2.2 into 10 to the power 9 into delta V upon V, that is 0.1 into 10 to the power minus 2. Let's evaluate it. So 2.2 into 10 to the power 9 minus 1 minus 2. 2.2 into 10 to the power 6, and pressure is Pascal, right, or Newton per meter square. So I think you have understood all questions fully. Thank you for watching. Team Educate